Things you shouldn't do with the 555 IC. In this session, I want to talk about what things we shouldn't do with the 555 IC, or in other words, what points we need to pay attention to when working with the 555 IC so that it performs better and we can get the desired results from our circuit. In these past 2 or 3 sessions we've had so far, I talked about some of the applications of the IC. And in the previous session, I also showed what exactly is happening inside the IC itself and how it works. Now, we're going to use what we've learned so far and show what things we should do to make our IC perform better and what things we shouldn't do, or what points we need to pay attention to so that our IC works even better and we can get good results from our circuit. So make sure to pay attention to a few points that I'm going to mention next. All right, if you remember from the last session, we introduced the pins and explained what each one does. Pin number 7 is the discharge pin, which, as we know, is connected to ground through an internal transistor inside the IC chip itself, meaning that's where we have 0 volts. Now, in this case, we need to keep in mind that the resistor we're using in our circuit should be an appropriate one, and it shouldn't be less than a certain value that we specify for that circuit. A small percentage of error isn't a problem, but if it's much less, for example, if I'm using a potentiometer or another resistor, and let's say the resistor is supposed to be 5 kiloohms, but I use a 100 ohm resistor instead, well, that's not correct. Why? Because what is the function of a resistor? It prevents the flow of current. I don't mean that it completely blocks the current, electronics. It's just that it only allows the amount of current that should pass through the circuit to actually flow. So if I use a resistor with a value lower than the standard amount, a strong current will flow through the circuit, and this can damage different parts of the circuit. Now, why did I mention this? Because when I want to connect a resistor to pin 7, I need to keep in mind that if, according to my calculations, I need to use a 1 kiloohm resistor, it should be in that same range, and it's better not to use a resistor much lower than that. It's more proper this way, because the lower the resistance, the more current it allows to pass through, and obviously that can cause my circuit not to work properly. The second point we need to mention here is about the capacitor that we use in the circuit, and we should also pay attention to a series of characteristics of that capacitor, or any other component we're using. One of these characteristics is impedance, which is the circuit's resistance to the flow or passage of electrons, or in other words, electric current. Now, to put it another way, it also refers to the resistance that an element or circuit shows when alternating current passes through it. In fact, we can say that impedance is a more general term than resistance. Now, if we're going to use a 10 microfarad capacitor in a circuit, depending on the output we're aiming for example, if we have a speaker output that's 8 ohms, then obviously a 10 microfarad capacitor would be suitable for us. If I use a capacitor, say a 100 microfarad capacitor, the impedance of this capacitor, especially if it's an electrolytic one, will cause a strong current to pass through our IC, and as a result, the IC will get very hot and might even burn out in some cases. Therefore, we need to consider the maximum allowable capacitance in our circuit based on the output we're using. As I mentioned, that output could be a speaker or it could be an LED lamp, and depending on those, we can arrange these capacitors accordingly. Now, how do we know, for example, which capacitor or what capacitance is needed, or which component with what value, like what resistance value we should use? Well, there are some circuits that have already been tested and refined through trial and error. So now you just need to use, for example, a 1 kiloohm resistor or a 10 microfarad capacitor in that specific context. If you use much more or much less than that, your circuit probably won't work properly. On the other hand, each component also has a data sheet that shows, for example, how much current is needed to run a speaker, how much voltage should be supplied, and it contains some other information as well. So when we're using an IC, we also need to consider which capacitor to use with it. The third point is about pin 4. We know that pin 4 is the reset pin, and in the previous section, we also specified which other parts pin 4 connects to. Try not to leave this part unconnected. Now, even though in the initial circuit we built together, I didn't connect pin 4 to pin 8, as we said would be better, the circuit still worked in the end. But to be more proper, I should have connected pin 4 and pin 8 according to a different arrangement. So try not to leave pin 4 unconnected, because if you do, some pulses can be generated in the circuit that might reset the chip's pin, which we might not want to happen in that situation. The fourth important point I want to mention here is that, in general, when you're drawing a complex circuit, you should always try to refer back to the main schematic related to the specific IC and connect all the necessary components to it in a very organized and logical way. Please don't swap the pins around or connect the various components in a messy, confusing, or scattered manner. Create a really good schematic so that if you want to show it to someone else, since it's arranged according to certain principles, that person can also implement it based on those same principles. There's a term we use in programming where we say, write clean code. Here, it means the same thing, that if the code is clean, it's easier to understand, and overall, running and executing that code will be better too. But if you draw the circuit really poorly, you might run into problems yourself in the future, and if you show it to someone else, it'll take them time to understand it. Those complexities might even keep you from getting the results you want, because sometimes you might be making the connections correctly, but the schematic, which should be the main reference, has the pins in the wrong places. Even if you've numbered them, someone else might assume that the pins are exactly where they're supposed to be and end up giving you a completely different circuit. So make sure to always arrange your circuits and connections according to the schematic standards for the IC and follow those exactly. The fifth point is that if we want to have long-term delays, it's better not to use large value electrolytic capacitors and very high value resistors. It's the same issue of limiting the current and the long time needed, for example, for the capacitor to store that energy. So when it comes to timing values that are 5 to 10 minutes or even longer, we can say that the 555 IC isn't really very reliable. So try to use the 555 IC in your circuits if the timing is under 10 minutes, as it works better for those cases. For that part, if you need longer timing, meaning if the interval is more than 10 minutes, then obviously we need to use other types of circuits. Now, if we want to give a reason for this, it's that when a capacitor starts to operate, let's say the charging current is between 1 to 3 microamps, and when it gets close to being fully charged, that current can drop to less than 1 microamp. Now, the current that's flowing doesn't pass completely through the capacitor. After all, along the path it's taking, there's some loss, and as they say, there's also some leakage. If the capacitor's leakage current itself is, say, about 1 microamp, then our capacitor will never fully charge, and as a result, our IC will never enter that standby mode. So keep this point in mind as well. The reason we say it shouldn't take too long, or that the capacitor's value or the resistance shouldn't be too high, is because, let me emphasize again, if these values are too large, it will take a long time for the capacitor to charge. And during that charging time, there will inevitably be some leakage. By the time the full charging cycle is supposed to be completed, there might be some loss, and this could prevent our capacitor from fully charging. The sixth point I want to mention here, which is also the last point, is that you shouldn't connect the output of the 555 IC to a PNP transistor. That's because the voltage at pin 3, which is our output pin, also labeled as out, doesn't go high enough to turn off the transistor. As a result, since it can't keep the voltage high enough, a lot of current gets drawn by the circuit, and in this way, we won't be able to run our circuit properly. So it's better and recommended that instead of using a PNP transistor at the output pin 3, you use an NPN transistor. All right, these were some points that you should keep in mind when assembling your circuit and designing with the 555 IC. I hope this part was useful for you as well, because we want to fully learn how the 555 IC works and be able to design our own circuits and move forward accordingly. In each session, I'll share a series of tips step by step. In the upcoming sessions, we'll talk about the different modes of the IC, like the monostable and bistable modes. We'll explain those as well. And together, we'll build circuits that demonstrate these modes. Thank you for staying with me up to this point. If you have any questions, be sure to ask them in the comments. If needed, we'll also make videos based on your questions. In fact, during this time, a few good questions have already been asked by some friends, and I'll definitely answer those in video form during the lessons. Thank you for staying with me up to this point. Until the next video, I leave you in God's care. Goodbye.